So here's a graph. Is this function continuous? I know I'm repeating myself a lot. Yes, I know you're going to say yes. Okay, so what happens at this point, because the function is continuous everywhere and at any point, the limit from the left and the limit from the right equal the function value, let's say, at a. Any value, a. So this is continuity at a point. The limit as x approaches a from the left of the function, the trend of the function from the left of a equals the trend of the function from the right of a and equals f of a. This is a very important definition. Please remember this definition. Very simple to remember, but you also need to remember how to put it in writing. The limit from the left equals the limit from the right, because the limit has to exist, right? The limit from the left has to equal limit from the right, either side, and also equal to the function value. That's why this function is continuous at that point. That's why this function is not continuous at this point. The limit from the left and the limit from the right are the same, but they don't equal the function value there. Same thing here. The limit from the left and the limit from the right, they're not even the same. So not continuous. The same thing here. Limit from the left is a number. The limit from the right is another number. So this condition is not fulfilled, let alone not equal to the function value. So a function is continuous at a point if the limit from the left equals the limit from the right equals the function value at that point. Okay, I want to share my screen now. I'll look at a couple of graphs. We finish with the limits. Okay, this determine whether each of the functions shown in the exercise is continuous over the interval -6 to 6. Is this function continuous from -6 to 6?
No.
No. And it's not continuous at which point?
-2.
When x is -2. Very good. What about 48? Is it continuous between -6 and 6? No. Can anyone give us the limit from the left of 1?
2.
2. The limit from the right of 1, please.
-1.
-1. Awesome. Good. Is this function continuous between -6 and 6?
Yes.
Absolutely. Is this function continuous between -6 and 6?
Yes.
Yes.
Careful. It's very tiny. It's very tiny. That's why you can't see it. It's right here at -1. It's that removable discontinuity. Right here. The limit from the left is 2. The limit from the right is 2, but it does not equal the function value. It has an open point. Is this function continuous from -6 to 6? What type of discontinuity is this?
Infinite.
Infinite. Awesome. Excellent. Thank you. Very good. Okay. So you will let me know if you want us to graph another piecewise defined function and establish if it's continuous from the left. I'm sorry, if we have something called continuity from the left, continuity from the right. We do have it, but it's not emphasized in this book. So let me just say this here. When there is the full point, we consider the function continuous from the left because the function value equals the value, the limit equals the function value. Here we will not say that it's continuous from the right because the trend or the limit does not equal the function value at that point. So do you think we can skip this because we've done it 3 or 4 times, or you still think that we should graph a piecewise defined function? If you say skip, I'll move on.
I'd like one more, please.
Okay. So So obviously with these two problems, because x is less than 0, x than 4 and x greater than 4, we shouldn't even discuss this. Is this function continuous at 4? Can it be? It doesn't even have a function value at 4 because the equal symbol is not there. So for these we have nothing to say other than the function is not defined at 4 and move on. For this one, I don't know. I have to determine. Okay, so let's look at 65. And in 65, which page am I on? Page 125. So we have f of x equals x plus 2 for x less than or equal to 3, and 2x minus 5 for x greater than 3. They want us whether it's continuous at 3 or not. Okay, so perfect. Can anyone give us the interval notation for these two?
The first one is negative infinity 3.
Awesome. Thank you, Sloan. And for this one, anyone? Cameron, can you give us this interval? I haven't heard from you today. Okay.
Give it a go.
No, yes, Ben. I was saying Cameron, so Cameron is not with us then. Okay, Ben, go ahead.
Yeah, my fault. I was trying to speak earlier in the class, but my mic was muted.
Yeah, I'm muting everyone so there is no noise, background noise. Forgive me. So please always.
No. I had like my headset mic up, so there was no way I could talk. But would it be 3 to positive infinity?
Awesome, with parentheses. So then I know the key number is definitely 3. I have negative infinity to infinity. We already know the domain is all real numbers. And remember, this is the bracket and the parenthesis, and they have to touch, and they have to be exactly under 3. This piece is for less than 3, so I use x plus 2, and this piece for greater than 3, so I have 2x minus 5. So we plug in, I wish I should also plug in negative 2 because I get 0. Plug in 0, I get 2. Plug in 3, I get 5. Plug in 3, I get 1. Plug in 4, I get 3. I don't have to graph. Can anyone tell us whether the function is continuous at 3?
No.
No, because the limit from the left of 3 from x plus 2 does not equal the limit from the right of 3, which is from 2x minus 5, and does not equal the function value at 3. At least one of them does not. So I will say not continuous at x equals 3. And this is the definition. If the limit from the left equals the limit from the right and equals the function value, then I'll say it's continuous at 3. But obviously, from the left, this whole number is 5. From the right, this whole number is 1. 5 cannot equal 1. Even if f of 3 is 5, these two are equal to each other, but they don't equal the limit from the right. So I will say not continuous at x equals 3, and it will be a jump. So how do I graph? Remember, do not let them overlap. That will be a tragedy. So negative 2, 0, 0, 2, and 1, 2, 3, 4, 5 here. So this is a full point. And then we have 3, 1, and then 4, 3. And I really wanted to use different colors just to refresh your memory and remind you that if you, so right here, there is only one point, this one. So the function is not continuous at x equals 3 because the limit from the left is 5, the limit from the right is 1, and the function value is 5. So not continuous at 3. Very good. Other questions for me? Okay. Thank you for your involvement. Except Cameron, if you're back, are you with us? Okay. Moving on, I would like to move on to 1.3, about which I have nothing to say because we already did this. The average rate of change. We talked about it last week. It's basically the average rate is the slope. If you go back to what we discussed last time, y2 minus y1 over x2 minus x1, but really written as f of x2 minus f of x1 over x2 minus x1. So we know that. So this, and this is that. Nothing to say. I'm just going to share my screen and type in, what am I typing in? I'm typing in 133, 134. Okay, 134. Good. So we can choose any function you'd like to choose and determine the average rate of change. We can pick numbers from here and find the average rate of change between any 2 years that you would like to study. For any function, we can pick from here median household income in the United States. We can pick from here total employment. It says here what type of employment from 2008 to 2012. You can choose any years. We don't even have to stick with this, and find the rate of change. I'll go back. We can determine anything here. We can choose any function. They're all the same. Everything is the same. So we are given a function, and we're asked to find the average rate of change, such and such, between 500 and 700. When W, the weight is this and this, and all we have to do is just create the equation, the slope, determine the slope and plug it in. So you choose. So we can move on. So we've done this. Do you want me to go back, or you want me to go forward? You can choose any problem. I'll go back after we look at this. Population growth. You tell me. There is nothing. I have nothing to say. You pick whatever.
Could we number 55?
Yes, perfect. Let's look at 55. Good. Oh. Perfect. 55. Good pick. So I'm on page 5. Okay, so 55, and this is on page 135, and they are giving us, it has been shown that the home range, okay, there's of a carnivore, okay, in grams can be approximated. So we have age of W, which is 0.11 times W raised to power 1.36. So find the average rate at which the carnivorous mammal's home range increases as the animal's weight grows from 500. So from W of 500 grams to, so this is W1 to W2 for 700. And then find this. Okay, and we'll analyze and what does this represent. So first of all, let's find the average. Good. So they're giving us the function. They're giving us W1. They're giving us W2. All I have to do is determine the function for W2, function value, determine the function value for W1, divide by their difference, and I get the average rate. So I have to determine age of 500. I have to determine age of 700. And here's how I recommend we do it. I'll share my screen. And I want to go to the calculator. I was just doing this with one of your a different class. Okay, so I go to y equals. I clear what I was doing with your colleague. And we punch in. How do I move this so it's not in the way? Okay. So the function is 0.11 x power. You know me, I already disclosed that. I'm in love with parentheses. I don't know what type of calculator you have. And some calculators require parentheses and these sophisticated ones don't. So I want to make sure that everyone gets a fair treatment. So I'm putting parentheses at all times, even if sometimes they're not needed. So second and table, make sure that you go to second and table set and you have the independent variable in the ask mode, just the independent. Okay, so second and table, and all I need to plug in is 500 and enter, and 700 and enter. I don't want to do it separately. I want to do it at once. So that's why I put the function in. Then go to the right column and highlight this, because then the calculator shows you whatever. Because actually the problem may say 4 decimal digits, and you don't have 4 decimal digits here. So that's why you need to highlight it to see the entire number. So I will copy only 2 decimal digits, 515.22. That's okay. I scroll down and I have 814.19. And this is in grams. Remember, we wrote that a long time ago. Measurement units should always be there. Now, what do? All I have to do in order to find the average rate between the points with the given x values, in this case w values, I have to create the slope. That's all. So the average between, I like to write it like this. You don't have to, because it tells me exactly what I calculated. So it's y2 minus y1 over x2 minus x1. Let's write it again just to make sure. Age of 700 minus age of 500 divided by 700 minus 500. So I copy the numbers. 814.19 minus 515.22. Be very careful. You just saw what I just did. Never rush with this, because if we reverse them, we're not going to get what we are looking for. One more time, just to make sure this is clear. y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So I would punch this in the calculator, but be careful how you do it, depending on what you are trying to do, second and quit. So put parentheses. It's always the best to create only one calculation, not increase the error by doing it step by step. We don't want step by step. We want 814.19 minus 515.22. Close the parenthesis and then divide directly by 200. So the rate of change is 1.49. I don't know how many decimal digits. I'm going to copy the whole thing. I didn't look and see how many decimal digits they wanted. But what is absolutely crucial is the measurement unit. Please, any average rate of change or any average rate is a ratio. The measurement unit has to be a ratio. The top measurement unit comes from the measurement unit of the numerator, and the bottom of the measurement unit comes from the measurement unit of the denominator. Okay, so I just realized that I did not look carefully. Okay, so this is the measurement unit for h. So I have another change to make. By rushing and not reading and not writing in my notes the measurement unit for each variable. Okay, I'm not taking my own advice. So the measurement unit for age is in hectares, and the same thing, right? But this is in grams. So the measurement unit for the top and the measurement unit for the denominator. So always the rate of change has two measurement units. Again, as an example, you're asking me, what is your speed? I'm driving home and you call me and you ask me what is your speed? I'm going to say 48. No, it's 48 miles per hour. Why? Because this is like the average or the instantaneous rate of change. So the numerator, distance, the denominator, time. That's why the speed is 48 miles per hour. The measurement unit for the top over the measurement unit of the denominator. Okay? Good. Do you think we need, oh yeah, we have part B. Sorry. Okay, can anyone look at this part B and tell us what this represents?